Did you know that every year we humans generate over 2 billion tons of municipal solid waste? That's enough to fill over 800,000 Olympic-sized swimming pools. For decades, the solution has been to bury it in landfills, but we're quickly running out of space. These mountains of trash are reaching capacity, and they release harmful greenhouse gases into our atmosphere. But what if I told you there's a way to transform this ever-growing problem into a powerful solution? What if our garbage could become a reliable source of clean energy? This is the world of waste-to-energy, or WTE, a remarkable process that turns our trash into treasure, powering our cities and creating a more sustainable future. The idea of burning trash isn't exactly new. The first incinerators popped up back in the 1970s. Their main goal was simple: reduce the sheer volume of waste. But they were inefficient, often smoky, and energy recovery was just an afterthought. Fast forward to today, and the picture couldn't be more different. Modern WTE plants are high-tech marvels. They're designed not just to burn waste, but to capture the immense heat produced and use it to generate electricity and steam. This energy can power homes, businesses, and even entire city districts, from Europe to Asia. These advanced facilities are becoming cornerstones of sustainable urban planning, helping cities drastically reduce their dependence on landfills while creating a local, reliable energy source. So, how does it actually work? There are three main technologies at the heart of WTE. The most common is incineration. In this process, pre-sorted waste is burned in a controlled environment at very high temperatures. This heat boils water, creating high-pressure steam that spins a turbine connected to a generator, producing electricity. It's a proven and effective method. Then there's gasification. This is a bit more advanced. Instead of just burning the waste, it's heated with a limited amount of oxygen. This converts the solid waste into a combustible gas called syngas, can be cleaned and then burned to generate electricity, often with lower emissions than traditional incineration. Finally, we have pyrolysis. Think of it as cooking the waste. It uses intense heat in a completely oxygen-free environment. This process breaks down the organic materials into a mixture of oil, combustible gas, and a solid residue called soot. Each of these products can be used as a fuel source. Modern WTE plants carefully choose the right technology to balance energy efficiency, control emissions, and recover valuable byproducts, making the entire process smarter and cleaner. Let's talk numbers. Just how much power are we talking about? On average, a modern waste-to-energy plant can generate between 600 and 800 kilowatts of electricity from just 1 ton of municipal waste. To put that into perspective, a single ton of trash can power an average home for nearly a month, and efficiency is constantly improving. Before the waste even reaches the combustion chamber, it goes through a sophisticated sorting and pre-processing stage. This is crucial. It removes non-combustible materials like metals and glass, which can then be recycled. By only using the high-energy fraction of the waste, the plant operates more efficiently and produces fewer pollutants. This integration of sorting, recycling, and energy generation is the very essence of turning trash into a clean, reliable power source. Now, I know what you might be thinking. What about air pollution? It's a valid concern. Early incinerators had a bad reputation for a reason, but modern WTE plants are a world away from their predecessors. They are not just incinerators. They are highly advanced chemical processing facilities. They are equipped with state-of-the-art emission control systems. We're talking about multiple layers of scrubbers, filters, and catalysts that work together to capture and neutralize pollutants like dioxins, nitrogen oxides, and fine particulate matter before they ever leave the stack. In fact, these plants are so strictly regulated and monitored that their emissions are often cleaner than those from fossil fuel power plants. And here's a huge environmental win by diverting waste from landfills. WT facilities prevent the release of methane, a greenhouse gas that's over 25 times more potent than carbon dioxide. So it's a double benefit. We reduce harmful landfill emissions while generating much-needed energy. Waste to energy isn't just about getting rid of trash. It's a key player in the circular economy. The goal of a circular economy is to eliminate waste and keep resources in use for as long as possible. WTE fits into this model perfectly. After the combustion process, it's not just ash that's left over. We can recover valuable materials from the bottom ash, like metals that weren't sorted out beforehand. These metals are recycled, saving the energy and resources needed to mine and process new ore. Even the remaining ash itself isn't wasted. After being treated, this incinerator bottom ash can be safely used in construction projects, as a component in road building materials, or even in the production of cement. This closes the loop, turning the final remnants of our waste into a useful product and reducing our reliance on virgin materials. In this system, waste is never truly the end of the line. It's just reimagined as a new beginning. This isn't just a futuristic concept. It's happening right now all over the world. Cities are leading the way, proving that waste to energy is a scalable and effective solution. Take Copenhagen, Denmark. Its famous Amagerbach plant is so clean and futuristic, it even has a ski slope and hiking trail on its roof. It provides clean electricity and district heating to over 100,000 households. In Stockholm, Sweden, the Hagdalen plant is so efficient that the city has virtually eliminated its reliance on landfills. They actually import waste from other countries to keep their plant running and their city powered. And in Osaka, Japan, they've taken it to the next level, integrating their WTE facilities with high-tech robotic sorting and AI-driven optimization to maximize both recycling and energy output. These incredible examples show us that when you combine advanced technology, smart public policy, and community support, waste-to-energy becomes a powerful tool for building sustainable, resilient cities. From a problem piling up in landfills to a clean energy source lighting up our homes, waste-to-energy plants are fundamentally reshaping our relationship with waste. They are tangible proof that with innovation and commitment, we can build a more sustainable future. As our cities continue to grow and our consumption patterns evolve, turning our waste into power will no longer be a niche alternative. It will be an essential part of a thriving, circular world. Thank you so much for watching. If you found this journey into the world of waste-to-energy fascinating, don't forget to hit that like button. Subscribe to our channel and ring the bell so you won't miss our next episode. See you next time.